Hello, this is Anthony Manning. This is for the physics final, question 9. This was the first create your own question problem and example. We were asked to make a question that focuses on calculating pressure during a temperature change and calculating the pressure if the volume is increased to 4 times its value. So the base rule of, one of the base rules of pressure and volume is that as volume increases, the pressure will decrease. And when it comes to temperature, the base idea is that the relationship is as temperature increases with the same amount of pressure, the molecules will fly around a lot more and the pressure will substantially increase. So as temperature increases, so does pressure, and as pressure increases, the temperature should increase too. Now, with that said, my question is, in a closed container that has 1 molecule of air inside of it, the temperature initially starts at 112 Kelvin and rises to 500 Kelvin. And then to calculate the two following, I start with PV equals NKT, the Boltzmann constant ideal gas law formula, and I use this formula as well, that V2 is equal to 4 times of V1, to substitute that in after solving up to this point and just plugging in the numbers. So when I plug this in and then I divide in order to start to solve for P2, I did B first because I had a lot of trouble with the first one actually. And when solving for this, I plugged in Boltzmann constant and I just plugged in all the numbers, and I ended up with 0.224 ATM. And ATM is the atmospheric unit of measurement of molecules in a space. P2 eventually boiled down to about being, with 4 times the volume, being 0.056 times pressure 1. Which makes sense because as you increase volume, pressure decreases. For the temperature, I did this relationship, the pressure and temperature relationship, and I just plugged in numbers and then solved for P2, and it turns out that there is P2 is 4.5 times the pressure of pressure 1 if you increase the temperature that much. Thank you, Professor.